Bună ziua!
Hello. In this video, we will talk about the autopilot of a UAV, analyzing the following essential aspects. Definition of a UAV autopilot and its main functions. Fundamental components of the autopilot system. Its operating principle. Specific operating modes of the autopilot. The autopilot is an electronic system that allows a UAV to perform autonomous or semi-autonomous flights without continuous human intervention. It analyzes the UAV's stability, direction, and trajectory using a combination of sensors, algorithms, and actuators. Main functions of the autopilot: maintaining stability by continuously adjusting tilt and rotation angles to keep the UAV balanced. Autonomous navigation by following a predefined route using GPS and navigation sensors. Obstacle avoidance by detecting and avoiding objects in the flight path. Error management by recognizing problems and initiating safety measures such as return to home, RTH. Motor and altitude control by adjusting motor speed and power to regulate altitude and direction. Autopilot components. The autopilot consists of a combination of hardware, sensors, processors, actuators, and software, algorithms, and control firmware. These include navigation and stabilization sensors. For autonomous flight, the UAV requires multiple data sources from sensors such as IMU, magnetometer, GPS, RTK, GPS, barometer, and LiDAR. Actuators and motor control. Motor control is carried out using ESCs. Servo mechanisms are used in fixed-wing drones or auxiliary systems. Communication modules used for transmitting and receiving data include telemetry, RC receiver, Wi-Fi, 4G, 5G, and LoRa. Autopilot operation involves several essential stages. Data acquisition from sensors. The autopilot collects information about GPS position for precise navigation, tilt, acceleration, and rotation for stabilization. Altitude. Barometer, GPS, sonar, LiDAR for altitude control. Direction. Magnetometer, dual GPS, INS, inertial navigation system for trajectory maintenance. Processing and trajectory calculation. The autopilot processes data and decides how to adjust the UAV's speed and orientation. Algorithms such as the extended Kalman filter, EKF, process data to create an accurate image of the drone's position. Advanced systems can use AI and machine learning for decision-making, generating commands for actuators. Based on calculations, the autopilot adjusts motor power and direction for stability, aileron or flap angles for fixed-wing UAVs, servo mechanism movement to control cameras or other accessories. Response to extreme conditions and emergencies. The autopilot can identify problems and take safety measures. For example, if the radio signal is lost, it activates return to home, RTH. If a low battery level is detected, it initiates an emergency landing to prevent UAV damage. When strong winds are detected, it automatically adjusts motor power for compensation. Autopilot operating modes. Manual assistance, stabilization mode, meaning the pilot controls a UAV, but the system provides stabilization assistance. Loiter keeps the UAV in a fixed position stabilized by GPS waypoint navigator. The UAV follows a predefined series of GPS waypoints. Follow me. The UAV follows an object using GPS or computer vision. RTH, return to launch or return to home. The UAV automatically returns to the takeoff point in case of an emergency. Examples of autopilot systems: Autopilot PX4, DJI Autopilot. Autopilot applications: military missions and surveillance, mapping and industrial inspections, smart agriculture, delivery drones and autonomous transport. In conclusion, the autopilot enables UAVs to fly autonomously, providing stability, precision, and safety. It combines advanced sensors, control algorithms, and actuators to navigate without human intervention.